So we move on to the second video under transformations of the complex plane as we consider rotation and scaling. In the last video, we considered the same topic, but we focused on translation, which was about Z becoming Z plus A. So in the case of rotation and scaling, let's see what we have here. So transformations of the complex plane, rotation and scaling. Basically here, transformation is about Z becoming AZ. In the last, for translation, right, it was about Z becoming Z plus A. So here it's about Z becoming AZ. So where A, you can see A as a kind of scaling factor here. So the geometric meaning of complex numbers, for instance, of course, we know a complex number Z is X plus IY, and we can represent it on the Argand diagram, right? With X on the Y-axis and on the X-axis and Y on the Y-axis. So, and this represents a point in the plane where X is the real part and Y is an imaginary part. And we have the polar form, which you had considered previously. I mean, in previous videos that I did like 2 years ago, So Z is now R into cos theta plus I sine theta. And that is equal to R E I theta because E I theta is the same thing as cos theta plus I sine theta. Where now this R, which is the modulus, is the modulo, R is the modulus of Z, which is square root of X squared plus y squared, and theta is the angle between this r and the positive axis and the horizontal axis, right? So, and that is arc z right there for you. Okay, so in 12.2, the transformation z mapped to AZ. That means if you let A be REI phi, then Z is REI theta, then AZ will have to be, normally this should be like in the last video, right? We said usually we like to take Z as X plus IY and as say P plus IQ. So we could actually do it that way, but this is also a very nice way of handling this kind of thing. So AZ is REI phi, this A here, and Z is REI theta. So if you multiply out R times R is RR, then EI phi times EI theta, that's EI phi plus e raised power I theta plus I phi. And then that's this big R times small r e raised power I into theta plus phi. And then, this is simply the same thing as small r times big R times small r into cos cos theta plus phi minus sine theta plus phi, going by the very idea we have here. Okay, so the key result we find here is this. Multiplication by A produces the following. It can produce a scaling by R, which is equal to absolute value of A, and then it can produce a rotation by phi, which is the argument of A now. So everything coming from A now is what produce the scaling and the rotation. So magnitude becomes RR and angle becomes theta plus phi. So the angle is increased by phi and the magnitude is multiplied, is scaled by small r in this case. So the summary of this effect now, the magnitude is multiplied by the absolute value of A, while the angle is increased by angle A. So the shape is preserved and orientation is also preserved in that sense. So we can then have special cases, right? We have special cases of scaling and rotation. We can have pure scaling. If A is real, then A is greater than, if for A greater than 0, we have scaling. But if A is less than 0, we have scaling plus rotation by pi. The example is when Z becomes 2Z, right? Z becomes 2Z. That's a good example of scaling. So we then have pure rotation. So for pure rotation, if the magnitude of A is equal to 1, then A becomes e raised to power I theta. Normally it should be R e raised to power I theta, but the magnitude of A now is R is 1. So absolute value of A is 1. So that is e raised to power I theta, I phi rather. Then we can say Z now becomes E raised power I phi multiplied by Z, or if you like Z e raised power I phi. That is the scaling that has happened, the rotation that has happened in that case. So an example is when Z becomes IZ. So you have a rotation by 90 degrees, that's pi over 2. Rotation by pi over 2 in that case, when Z becomes IZ. So let's look at some examples like that. So let A be 2EI pi over 4 and Z is equal to 1 plus I, right? So step one, since this is like in polar form already, you want to also convert this one to polar form. So convert Z to polar form. And to do that, Z is R-E-I raised power theta. R-E-I, R-E, R-E raised power I theta, yeah? So absolute value of Z now is square root of 1 squared plus 1 squared. That's square root of 2 easily. Then argument of Z is, theta, that's 1 over 1. That's arctan of 1 over 1, which is pi over 4, right? So that's 45 degrees. And with that in place, then you can apply the transformation. AZ now becomes for A itself, A is 2 e raised by I pi over 4, and then Z is root 2. So that's 2. So the 2 from here times this root 2, that's this 2 root 2. Then talking about the angles, you have I pi over 4, and then this is pi over 4. So if you put the two together, so you have I pi over 4 into pi over 4. That'll be 2 root 2 e raised by I pi over 2, basically. And that's what you've got. So if you convert it back into this form, uh, that's like, so that conversion back is like, okay, it's just like converting these 2 root 2 e raised by I pi over 2. That step has been jumped, but I'll try to do that. So you have 2 root 2 e raised by I pi over 2. So that's more like having 2 root 2 multiply by cos pi over 2 plus I sine pi over 2. Okay, pi over 2 is 90 degrees, by the way, and we know already that cos 90 is 0, but sine 90 is 1, right? Sine 90 is 1, so that's I, and sine 90 is 1. So that means we have 2 root 2 into 0 plus I. So that means that's why we have 2 root 2i, or if you like, I 2 root 2. So that's why that is 2 root 2i over there. So this is why this is 2 root 2i. So in example 2 now, you have z to be 3 minus I. Okay? So a then is e raised by I pi over 2. So in this case, it feels more convenient to convert the polar form to the real form because this is pretty good. This is cos 90, cos pi over 2 plus I sine pi over 2. Cos pi over 2 is 0. So I sine pi over 2, sine pi over 2 is 1. So that's why this one is only left with I. So AZ is simply I multiplied by Z. So you have 3I minus I squared. I squared is minus 1. So minus minus 1, that's plus 1. So AZ here is 1 plus 3I. So this represents a rotation by pi over 2, as you can see here. So that's rotation by pi over 2. And for example 3, if you let a be minus 2, that's the scaling factor, and then z becomes minus 2z. So what's the effect now? So z is minus 2z. So the scaling is by 2, and then the rotation is by pi. So you have a 180 degrees rotation. That's what pi is. And that's as a result of the negative value, if you ask me. So, and then we can show that here using plots like we have here. So it's more like, imagine you have this re original rectangle now. Then if you now scale it by AZ by a factor of 2, so you have this rotation in orange color in that regard. So we have important properties. First of all, multiplication by A preserves angles, maps lines to lines, maps circles to circles. The angle part goes to the angle, the magnitude part goes to the magnitude, right? And it preserves shape up to scaling, and this is a conformal transformation. You remember the other time when we looked at translation, right? We saw translation as a kind of rigid transformation, which is isometric in nature. So, but here we have conformal mapping, preserving angles, mapping line to line, mapping circle to circle, and all of that. And it's preserving shape. And that is why the shape is preserved, but of course, there might have been a rotation. Then we have comparison of transformations. So if Z is mapped to AZ and Z is mapped to BZ, then we can have a composition such that Z is mapped to BAZ, like that. So the effect is that you have scaling factors multiplying and then angles are added, like that. So it's like everything is amplified by the double scaling. So we can also talk about inverse transformation. If Z is mapped to AZ, then inverse then of inverse is Z being mapped to 1 over A multiplied by Z. That's inverse transformation. So the key takeaways from here is that when Z is mapped to AZ, it produces rotation and scaling, like we've seen before. Like in that polar form, we see the magnitude multiply magnitude, and then the angle being added together. Then we have polar form simplifies multiplication, and magnitude multiplies angles add. Okay, magnitude multiplies and angles add. Then transformation preserves shape. So we come to the practice problems, and as usual, I'm going to take two of them. I'm going to solve two of them. So this is question 1 to 10, and then you have question 12 to 20, 11 to 20 rather. So of this, I'm going to solve problem 6. So I'm taking problem 6. Find the magnitude of Z equals 2 e raised per I pi over 3 under Z uh, mapped to 3 e raised per I pi over 6 Z. And then I'm taking question 20. That's the last question. If Z maps A to Z, if Z maps AZ maps 1 to 2 plus 2i, then find A. Of course, just like what we did in the last video, right? Automatically, Z is equal to 1, and then we need to figure out whatever A is, because this is now AZ. But, I mean, let's go for that on the worksheet. So, uh, problem 6 now. Problem 6. So, we are given Z equals 2 e raised per I pi over 3. Pi is 180, right? So that's 60 degrees there, so that can help. Then the transformation we have from the question, the transformation is such that Z is mapped to 3e raised per I pi 3e raised per I pi over 6 Z, like that. So so it means we need to compute. We now need to compute, we need to compute AZ. So AZ now will have to be, this is Z here, and this is AZ. Okay, what exactly are we looking for? I think that's important. Well, question 6, right? Find the image of Z equals that under Z mapped to all of that. Okay, so just go on. So we compute AZ, right? That is 3e raised per I pi over 6, and Z is 2e pi over 3. And as we already know, this means that 3 multiplies 2, this 3 and 2, we multiply, and then we have e raised per I pi over 6 multiplied by e raised per I pi over 3. And from the law of indices, AZ, of course, 6 e raised per I pi over 6 plus pi over 3. So pi over 6 plus pi over 3. Let me do this. Let me change this here. Pi over 6 plus pi over 3. Pi over 6 plus pi over 3. LCM is 6. 6 and 6, 1. 1 times pi plus 3 and 6. 2 times pi, 2 pi. That is 3 pi over 6. That is pi over 2. So we have this to be pi over 2. So we can then come back and know that AZ is equal to 6e I raised by pi over 2. And it's always sweet working with pi over 2 if you remember, right? Because now this is AZ equals 6. E raised by pi over 2 is like cos pi over 2 plus I sine pi over 2. Again, that's AZ equals 6. Cos pi over 2 is 0. That's cos 90. I sine pi over 2 is 1. Okay, so AZ is simply 6i, because this is 6 into I. That's AZ is 6i in the Cartesian form. So we have AZ to be 6i. So, and that is the image we are looking for there. So that's the image there, and that's our A and AZ. Okay, so with that out of the way, we go to question 20, problem 20 now. So for problem 20, let's see what we have. This is problem 20 right here. It says if Z maps to AZ, maps 1 to 2 plus 2, I find A. Okay, just want to find A here. So we are given Z mapped AZ, and the actual mapping is 1 going to 2 plus 2I. So we see here that A is okay, at least we know Z, right? We know Z is equal to 1, right? And then AZ is equal to 2 plus 2I. So what we are looking for now is this A. So how do we find that? So we know that so AZ is 2 plus 2I, but Z is 1. So that's and then so that means A multiplied by 1 is equal to 2 plus 2I. So simply A itself is simply 2 plus 2I. Easy peasy. So this is our A. But if you want it in polar form, so in polar form, that's optional. In polar form now, we have we need in polar form, A should be absolute value of A, then e raised power I phi, if you like. So how do we do that? So absolute value of A now is square root of the A we have, that's 2 squared plus 2 squared. That is square root of 4 plus 4, which is square root of 8. And that is 2 root 2 settled for this magnitude. Then for the phi now, we need to find, we know that tan theta is equal to y over x. This is x, this is y. So we know that tan theta, or tan phi rather, is y over x. That means that tan phi is 2 over 2, which is 1. So that means that phi itself is arctan of 1. And tan 45 gives 1, right? So phi is 45 degrees, which is pi over 4. So what does that mean? It means that so A, which is 2 plus 2I, is the same thing as the magnitude 2 root 2 e raised power I pi over 4. That's another way to have that. And with that, we come to the end of this video. We come to the end of this video talking about transformation as it relates to rotation and scaling. That means Z going to AZ. For that's transformation, right? Rotation and scaling. For translation, it was Z going to Z plus A. Here, for rotation and scaling, it is Z going to AZ. So don't forget to try your hands on the first 10 questions and, of course, the last 10. So I've done one from each side. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel already, I thank you very much for doing that. And if you have not subscribed, the question is, what exactly is holding you back? Why not go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel by clicking on join. That gives you some special privileges like getting to see some videos before other people, or seeing some videos exclusively that no other person sees, because you are special and because you're as a member of the channel, you have such an access. You can also request for PDF copies of my notes. We can also hang out together, to discuss whatever interests you on my channel, be it mathematics, data analysis, data science, machine learning, scholarships, anything at all that interests you on this channel. All right. Ultimately, don't forget to comment, like, share so that more people can have access to the great content I have going on here. Until I come your way again, keep doing maths right. Bye.